So now I think the moment we've all been waiting for is to get to our distinguished panel discussion. Chris and I will be doing some of the moderation here on that, but we're not as important, of course, as our esteemed panelists. So I'm going to jump forward a slide here, talk a little bit, and I'm going to throw it to each of our panelists so they can introduce themselves a little bit better. Just to let you guys know who are joining us as participants. We can take a few questions. I noticed I was trying to answer one or two of them in the chat as we went along. We may not be able to take all the questions for our panelists that come in today, but if you do have some and you want to use our chat function here in WebEx, we will try to include them as best we can. It's really going to be a limitation of my ability to manage multiple screens at one time to make that happen. But without further ado, I would just like to introduce our panel in order here. And I'll start with Andy Lacker, who is the Chief Technologist for Future Airspace Operations, Intelligent Flight Systems at the NASA Langley Research Center. So I'll just do a quick audio check. Andy, are you out there? And if you are, can you jump in and tell us a little bit about your work and experience in the field of autonomy and emerging technologies?
Sure. I'm assuming you can hear me, correct?
Yeah, I can hear you. Great. Thank you, Andy.
Okay,
oh, now
great.
I can see you too, so that's even better.
Okay, well, I'm an aerospace systems engineer. I've had a varied career. The last 20 years or so has been focused on the safety, security, and operational integration of unmanned and autonomous systems. I've worked most of my career from a government perspective, including 30 years at MITRE, a short stint at Noblis, as well as a bit of time on the commercial side working at Boeing and a couple of airlines. Right now, I'm a NASA federal employee where I work looking to the future of how we are going to enable unmanned and autonomous systems, as well as other new aviation technologies, function in future airspace. And I'm based at Langley Research Center in Hampton, Virginia, in the Intelligent Flight Systems Research Directorate.
Awesome. Thank you, Andy. Great stuff, and it's great to see you again. Moving on to our next panelist, sort of from the left to the right, is my client, Kate Hartman, from the ITS Joint Program Office at the U.S. Department of Transportation, where she's the Chief of Research, Evaluation, and Program Management. So Kate has a quick audio check. I just see if you can jump in and tell us a little bit more about yourself, your background, and where you think you fit in sort of this world of getting emerging technologies into widespread operations or integrating it with mainstream operations. Kate?
Hey, thanks, Carl. I appreciate that. Hi, everyone. I'm Kate Hartman, as Carl said. I am with the U.S. Department of Transportation in their ITS Joint Program Office, where we do a lot of the department's coordination on intelligent transportation systems for the transportation network. And that involves working with all the modes, pretty much very little with FAA. So we're really looking at landside type vehicles and a little bit of work at the ports. Most recently, I have been working in the connected vehicle space, and we're just finishing up large-scale pilots in New York, Wyoming, and Tampa. I am currently serving as the AV program manager. We had a retirement and are furiously trying to find a replacement, but it's the intersection of connected and automated, and it's been an interesting ride going through that. So looking forward to the panel.
Awesome. Thanks so much, Kate. Next on my screen here, we're going to move over to Dr. Khan Osbe, who joins us. He's a professor at the Department of Civil and Urban Engineering and the Center for Urban Sciences at New York University, but he's also somebody I've known for maybe 30 years. So Khan, if you want to jump in, we'll do a quick audio check and tell us a little bit about yourself and some of the work you're doing in the world of getting autonomous machines at scale of working in an urban environment. Khan?
Yeah, thank you, Carl. I hope you can hear me well. So I'm Khan Osbe, and I'm a professor at New York University, Department of Civil and Urban Engineering. As Carl said, I'm also the director of the UTC Tier 1 C2 Smart, where we really focus on urban problems from a big data and other AI kind of perspectives. So my interest with actually autonomous systems started many years ago with the funding that we received from FTA, and looking at how we can automate buses, obviously in the simulation, using the XPR dedicated bus lane on Lincoln Tunnel, and what kind of improvements we can get. And then we did this study, we kind of showed that in the simulation, you could really get 25% of flow improvements when you had these kind of autonomous buses. So, and then as time went on, we worked on these problems and really trying to understand what we could do in terms of automation and connected vehicles. They go hand in hand in big cities, and then we actually completed in collaboration with New York City DOT one of the largest field deployments, New York City pilot test for connected vehicles. And then actually, it was a great experience. We learned a lot. As usual, these kind of technologies, they work great on the simulation, but that field work is always a challenge. And we hope that we can use some of that knowledge to kind of take the autonomous and automated vehicle technologies to the next stage, basically deployment and not really large scale, but first limited, then large scale deployment, and see how we can improve the transportation system. So I hope that gives an idea about the things that we are interested in doing.
Awesome, great. Thanks, Khan. Our last panelist here is someone I just met, Greg Hayes, who I believe may be joining us from South Carolina today. I believe he's located in Charleston with the U.S. Navy at Niewek Atlantic. Greg is the Director of Rapid Prototyping and Experimentation. So Greg, I don't know if you can just jump into a quick audio check here and tell us a little bit about your work with autonomous systems and some of your experience. Greg?
Yeah, will do. Thanks, Carl. Good afternoon. As Carl said, I'm with the United States Navy. I have about 20 years in the government and about 12 on the outside, sort of in between that, pushing a lot of disruptive technology and rapid response type of opportunities. So in my job, I have what's called sort of speed to mission, where I try to rapidly go out and identify, adapt, and implement new technologies and capabilities faster than our adversaries. I'm currently putting autonomous systems in what I call real-world experiments. This big blue thing behind me here is a huge playground that we do a lot of autonomy testing in. We do some of it in international waters. It gives us a little bit more flexibility for doing some testing. But I'm also, quickly realizing that it's really not necessarily a technology challenge for the most part. It's the culture around all the aspects of autonomy and kind of how that plays into, one is the traditional way we acquire and partner with industry, but also just the legality and some of the missions that we do in the Navy, trying to have that level of trust that we mentioned earlier. So I do have a lot of appreciation for the commercial sector. There's a lot of techniques and opportunities out there now to try to bring in the autonomy technology and the AI and machine learning pieces to realize that the quicker we can get it in our environment, and our environment is quite a bit different because we don't always have connectivity guaranteed. We don't always have the ability to have reach back to the cloud. We don't have the ability to use the traditional radio frequency, Wi-Fi, cellular type of linkages. So that offers a lot of disruption. But we wanted to try to get the technology out in our environment so we can essentially make it smarter, right? Because autonomy is only as good as the environment that it's in. So the sooner we field it, the sooner we get it out and experiment, the smarter the systems become, and then it starts changing the way we utilize those. So I look forward to the questions. Thank you.
Awesome, thanks, Greg. I think just from the introductions, it's clear how much interest there is in autonomy, in these emerging technologies, and trying to grab hold of some of those opportunities by deploying operationally. But it's just not an easy walk to get there. We have a few kickoff questions here. I'm going to move through them as the sort of our starter for today. The first one is for Andy. So Andy, your kickoff question is: so NASA is a leader in autonomous systems, given the nature of managing operations distant from human control. So when you think of autonomous operations in close proximity to humans, what topics are critical to understand and ensure are working correctly? So Andy, if you want to jump in, and after Andy has his remarks, we ask the panels to jump in as well if there's anything that they'd like to talk about. But for right now, we'll throw it to Andy for his response.
Yeah, my focus is on aviation in a civil context. And when you fly in the national airspace as a civil aircraft, you're integrating, if it's an autonomous flight, you're going to be in and around other flights that may not be operating under autonomy. They may be operated by a pilot, they may be flown remotely. And you have to find a way to coexist with these incumbent operators in the system. And I like what Greg said about, it's not always the technical challenges which are the hardest. Some of them are the policy and procedural and operational challenges associated with integrating these aircraft into a single operation. And so when you think about aircraft that are flown without a pilot, that are flown where software effectively is the pilot, how is that aircraft going to follow the rules of the airspace? Most of us are drivers, and we can imagine driving a car. Well, if we're going to have a driverless car, the driverless car has to drive on the same road with me driving a car. Well, in aviation, we have the same challenge. We have an autonomous aircraft has to fly with others. And the other challenge that we have is because we can take the pilot out of the aircraft, we can make aircraft that are really small and that could be flying and doing missions where we don't currently have aircraft flying today. We basically expand what we can consider as navigable airspace. And that means we are potentially putting aircraft in close proximity to people who are not aviation trained. So today, the airport area is tightly controlled, and the only people who walk on an airport tarmac are people who are authorized to walk on an airport tarmac. But now the airport can be everywhere. We can have aircraft that can basically land anywhere. And that creates new challenges, including, if an aircraft is now delivering packages to my driveway, how are the little kids in the neighborhood and the dogs going to respond to that aircraft? And how are we going to make sure that that operation is still safe? And so those are some of the challenges at NASA that we're looking at as we look at autonomous flight. How does this autonomous flight fit in to the rest of aviation, and how do we ensure that it continues to be safe?
Yeah, great point, Andy. I look forward to having aircraft land in my driveway. I think there's just enough room there for me to get back and forth to work, so I appreciate that. And I would also like it not to hurt me or my neighbors, so I 100% get that. I guess ask if there's any follow-up question on that particular, any other comment from our panelists, or I've also throw it to Chris here. If you guys have a follow-up on the notion, not just on Andy's landing his autonomous aircraft on my driveway, but anything else related to the humans, the human mixed environment with the autonomous machines. So I'll just.
So Carl, I'm going to jump in since Andy mentioned driving
for
cars. Yeah, so it sounds like we've got a lot of similar issues, and how long is it going to take to get a fleet turnover? Is just one thing, but then how do you address the timing and how they interact? And if they are truly autonomous, are they really looking out for? I assume they're looking out for themselves, which may not be looking out for the system as a whole. And is that something we want to do? And if you're trying to optimize for the system, you're going to want some kind of connectivity. And we've been working on that, but as you said, as Greg said, the challenge isn't the technology. For us, we call it the institutional issues, because we've got 50 states with MPOs and individual cities, and then we've got car manufacturers, and then we've got regulatory bodies within the department. So, it's a challenge. So glad we're not alone in it.
Right on. Yeah, that's part of what we thought we might have this session, because we thought there would be some connectivity. So thank you so much, Kate, for your observations. I'm going to jump forward to our next kickoff question. This one's for Greg. So Greg, get ready. It's kind of a long question, so I guess you got some time to think about it. Recent events in Ukraine and elsewhere have generated a lot of press related to unmanned drones as tip-of-spear kinetic applications in the battle space. What are your thoughts on the potential value of autonomous systems in these situations versus, let's say, more prosaic logistical functions related to things like recon, refuel, resupply, and maintenance? Greg?
Sure, that's a great question. There is no doubt that commercial technology is changing the way we fight the war. I mean, even outside of the unmanned, but things like the SpaceX's Starlink, rapid deployment, and then also the rapid updating to counter the Russian jamming was a testament to just how thriving our innovation ecosystem really is in the United States. As far as the drones, I mean, we're seeing a lot of press now from the Switchblades or the Phoenix Ghost. There's no doubt. I mean, the bombs and bullets is what gets the press and what gets the Congress excited and a lot of resources. But I think any military expert will tell you that it's logistics that win the war, right? So our ability to deploy, replenish, and sustain forces will actually, is what usually determines the outcome. So in the Department of Defense, we use the terms like contested logistics or resilient logistics, and it's the ability to looking for unmanned solutions and autonomy to expand our operational reach, trying to find ways where we can deliver fuel, munitions, and other material where we need it and when we need it. And a lot of it is in harm's way. So it's a lot of the same challenges I mentioned earlier about you don't have connectivity guaranteed. You don't have the ability to replenish close by. You don't have the ability. So there's a lot of challenges out there. And what we're trying to do now is play those scenarios out and see, how that really does change. Because, for example, unmanned vehicles on the ocean, at some point they got to refuel, right? So right now when two ships refuel at sea, I mean, we sort of have to turn off all of our gear when we do this sort of dance between two manned vessels. And if one's unmanned, it's kind of hard to do that. So trying to get to true relative position, to close, launch and recovery and things like that continue to be a challenge. But it's the logistics side that's starting to put a lot of energy in that area. So in the Navy, we have we just set up the unmanned campaign framework. It's publicly available. It released last year. It talks about the levels of autonomy. It talks about from the human being in the loop all the way to true autonomy and some of the attributes of that. And then we also are starting to do some experiments in this area with we just got one with the Office of Naval Research down in JIDA South, which is in Key West, that does all the southern drug proliferation and illegal trafficking challenges. It makes for a very good experiment because you're not necessarily firing any weapons. So you can do a lot of logistics type of scenarios and try to go after the big data challenges and the unmanned areas that's very real world scenarios that could be then applied to sort of something, say, in theater. Over.
All right, so Chris has got a question. Chris, you want to follow up?
Just a quick follow-up. Thank you, Greg. Just curious what the level of coordination is between the services that you're seeing so far in autonomous systems, in the frameworks and the technologies and joint operations. Comment on that briefly.
Yeah, Chris, can you repeat that, or Carl? I couldn't hear him.
Well, I don't know. Maybe Chris might be muted. Are you back on, Chris? I don't want you to go ahead.
Can you hear me, Greg?
I can hear Carl really well. I can't hardly hear Chris.
All right, I'll reformulate that. I'll see how well I listen to Chris. I'll try to say his question for you. All right, so the question was, so that's great stuff that the Navy's doing. Do you see a lot of connectivity with your other parts of the military, other services? Are they, is there, in terms of a common framework, Navy, are you working together with the other parts of the services, Army and so forth, to manage autonomy in an effective way, or is it pretty much Navy's got its own set of problems and you're working on those?
No, we do. It's a lot of it's in the experiment venue where joint capability demonstrations and these other things that have a lot of cross-service, a lot of priorities being placed in cross-service type unmanned experiments to do exactly that. We also got a good bit of international. We had a big international experiment in February over in the Bahrain Gulf area called the International Maritime Experiment, IMX 22. It had a lot of different countries because there's a lot of unmanned autonomous technology going on globally that is pretty impressive as well. So to bring them into the mix is pretty powerful too. Thank you. Good question.
Great, thank you.
Thank you.
We'll make sure we get Chris's mic fixed over here so he can ask questions. Can't always pass it through me. All right, our next kickoff question is for Kate. Kate, nearly every vehicle sold in 2021 had some form of wireless connectivity as well as augmented driver support, ranging from things like blind spot warning to automated lane changing. So are our roadways already autonomous systems, or are key technologies like wireless connectivity still evolving? Kate?
Well, the short answer is it's still evolving. The longer answer is if you consider a person to be able to control an autonomous a vehicle, then every vehicle right now is autonomous. But if you mean machine control, we're not quite there yet. I like to tell the story. I had a family member get recently purchased a new car, and we could talk about the supply chain and how long all the issues that influence that and how autonomy may be able to help. But anyhow, they bought the car and they were all excited to tell me about they got almost an automated vehicle. It had all these cool features on it. And as he started telling me, I was like, it's not automated. You still have to be in the car. You still have to control it. And the things that you're talking about are nowhere close to where the technology it can take you. So I think there is some misperception by folks about what exactly an autonomous or an automated vehicle can be and will be, but there's been a lot of hype and a lot of press in the last few years about we're ready to bring it. We've got one relatively new OEM that has been at the head of the hype cycle. So there is a lot of misinformation, and there is still, a lot of work to be done, especially in the connectivity part, if that's going to happen. So that's where we stand right now.
Yeah, great answer, Kate. And I'd have to say, people have seen a lot of autonomy in CGI in movies, and they think that's the world they live in, right? But the reality is somewhere in between. I don't know if there's anybody else. I think Andy was about to jump through the screen. Yeah, I was going to say
Yeah,
on this topic. If Andy, you want to tell us a little bit about some of your thoughts about this? Go ahead, Andy.
Well, we have a really nice current event to give an example. In aviation, we've had autopilot and auto throttle for years. Doesn't mean aircraft are autonomous. You need the pilot to set those features, and those features don't get you to land. So yesterday, coincidentally, we had an aircraft that had a pilot who became incapacitated, and a passenger took over the aircraft and with coaching from someone on the ground was able to land that aircraft. That aircraft had auto throttle and autopilot on it, but you needed the passenger with tremendously excellent coaching from the ground to be able to land that aircraft. And that was quite a miracle, to be quite frank. But we don't have autonomous aircraft. Now, there is a feature that has been recently certified by the FAA as a backup emergency feature in the case of a disabled pilot, an incapacitated pilot. There is a system that you can press a button, essentially, and the aircraft will choose an appropriate airport to land in and head to that airport and do the radio calls and everything that's necessary to land in an emergency fashion. And for that circumstance, in an emergency, you have an autonomous aircraft. But that's a brand new system, and it's only available, I believe, on 2 aircraft models. And I don't even know how many are actually deployed, how many individual systems are actually deployed in the field. The aircraft that was in the incident yesterday did not have that system on board. But it was what it was created for.
Yeah, and to be clear, there are automated vehicles out there that have been in some limited piloting and demonstrations, but they are by no means anything that you can go to your local car dealer and purchase today. So it sounds like
to go
similar.
To car dealer, have it drive home for you. We're not there yet. Although some people I talk to that are owners of certain kinds of cars believe that they can, but they have not successfully done it. Great. Our last of our kickoff questions, we'll come back to this one, I think, Greg. I think that the whole question of where are we really in autonomy is going to color the rest of the conversation for sure. But we'll wrap up our final kickoff question with Khan up in New York. So Khan, your question is, from the perspective of a resident and researcher in New York City, considering the introduction of increasingly automated vehicles, taxis, buses, and delivery drones, what do you see as the most important potential impacts on human behavior and the resulting change to the urban environment itself? Khan? Oh, Khan may be on mute. I don't hear him. Kate, can you hear Khan? I don't think I hear him.
I can.
Good,
He's on
good.
mute.
All right, good.
There
Sorry.
you are. Okay, great. We got it. Thank you.
I was trying to. So, I mean, what I was saying is it's a loaded question. It's a lot of assumptions that human behavior changes independent of everything else. In our business, obviously, in transportation, human behavior is really affected by so many things. And actually, there's a wonderful book by Marvin Manheim that I use in my class, Fundamentals of Transportation Systems, where he kind of puts together different components, different things that affect human behavior in terms of travel. And of course, I think if I want to summarize what I get from this question is that, how the human behavior will change is basically due to the availability of this technology. So we talked about it, everybody mentioned, if the technology is already available, we might think that it's available, but it might not be. And what is the full cost of that technology? It's not just purchasing, but operating and maintaining and so on. So, I mean, we just need to think about these things when we think about human behavior and its impacts. I think a couple of things I can say about individual impacts. That means just people who are commuting. If you have a fully autonomous system of vehicles, trip-making decisions will change, definitely. Probably people will take longer trips, the parking behavior will change, and so on. I believe that, and some people might disagree with me, the safety will change. The system will become safer because we will eliminate human errors. As a result of these two things, I think the land use will change. So I'm thinking like a big picture. So the way people, where they live, how they choose to, locate their houses will change. And as a result, maybe it's not a good thing. I think vehicle mass travel might change if you have fully autonomous system. But I think we also need to think about from the perspective of freight, trucks, and so on, because I think in terms of freight, it will have huge impacts on operational aspects of freight. So we might be able to operate, for example, longer hours, off hours, and so on. So there'll be a better capacity use of the system because you don't need human drivers. On the other hand, there might be some negative impacts, which we talk about it in New York City. There'll be higher barriers to entry by mom and pop type of companies. These trucking companies, actually, a lot of them are mom and pop, so you can buy a truck and then start your own company. But if it's an autonomous truck, I think it'll be a more centralized system. Big companies might become the dominant players. And then there might be new submodes of freight, like for last mile deliveries, drones, and maybe a more improved logistical system of trip chaining and so on. So just to summarize, I think it might have this autonomous level 4, level 5 type of autonomy might have positive improvements in terms of safety, capacity, in many cases, and there might be less traffic congestion because there might be less accidents and so on. But it might also some unexpected impacts of even employment, of how the trucking companies evolve and how people live. They might live further away from the cities, so urbanization will be affected. So there will be, super far away suburban locations. So I think, one couple of few points. I think the robustness and the cost of autonomous systems will dictate the success or adoption of these technologies. Probably you need a killer app, like something like will take over. It will impact everybody's perception about the systems. I don't know what is that killer app, but probably you need that. But in any case, the adoption of this technology will be slower and incremental, and not only due to the technology, but also the policymakers, lawmakers. Because I talked to local DOT, for example. They don't know what to expect when you have 10% of the vehicles are autonomous. Just they're not ready to write the law to regulate them. It's different than just doing some pilots. And then, this is, again, I don't know. I was thinking about it. The breakthrough, probably in terms of widespread use of these fully autonomous vehicles, might come from outside the U.S. And a good example of that, cell phones. Cell phones, actually, if you remember, was not like very widely used, especially smartphones, for a long time in the U.S. When you traveled to Asia, to Europe, you saw more people using these cell phones, and then all of a sudden it picked up in the U.S. also, and then became very widely used. So maybe it might come from Europe. We know, for example, they're pushing the autonomous trucks very heavily because of labor concerns and safety concerns. I don't know. Maybe that might be the killer app coming from an outside location of the U.S. That's just a couple of ideas.
Awesome. Thank you, Khan. I don't know if there's anybody has a follow-up on Khan's response there, or any change to the urban forum. Chris, you okay?
Yeah, the question I would have, you can hear me, Con. Carl, repeat it. But when you look, when you look at the municipalities and the cities, kind of similar to the answer to Greg. Where do we see some significant cities, municipalities taking the lead, taking some of those first steps? You see that in New York City amongst deployment of autonomous vehicles or pilots, or are we just not there yet?
I think New York City is very careful about separating connected vehicles from autonomous vehicles. So New York City is perfectly all right, as far as I know, with connected vehicles. But when it comes to autonomous vehicles, I don't think they're ready for it. Many cities might be doing some low-level testing, but I don't know any city who's really ready to go full-fledged for autonomy.
All right, great. Thank you, Khan. All right, so those are our initial questions. Now we'll move into some toss-ups. So I'll actually, for our panelists, I can see you very well on my little screen here. So if you feel like you want to answer the question after I throw it out there, just raise your hand. I'll throw it to you. It's the simplest of way of signaling human intent, I think, since the dawn of time. Machines have a hard time understanding that, but we know each other, right? We evolved together as humans. So we're going to use that mechanism of coordination here. Just raise your. You don't have to do any of the other functions in chat. Just raise your hand, and I'll throw it to you. All right. So question number one, a toss-up. So one way of engineering a way out of multi-machine coordination is to create purpose-built teams or templates for specific situations. But the weakness, as James pointed out, is that these lack flexibility. So, but any insights on where ad hoc coordination is absolutely needed? I don't know. Oh, Greg is a taker for that one. Go ahead, Greg.
Yeah, so in the military, we sort of call these swarms, right? And there's a lot of offensive and defensive advantages of doing that. And you have a lot of challenges with sense and avoid and coordination, but they offer the ability to reach into this environment that I mentioned earlier that's sometimes disconnected and very challenging, because they can sort of breadcrumb their way in, or sort of ad hoc exchange data and process on the edge, and allow the ability to tie in multiple sensors, potentially decoys and things like that, to sort of overwhelm potential enemy with a lot of very clever small very affordable assets.
Great. Andy's got his pen up. Andy, go ahead.
There's a hand attached to my pen. I think anytime you have a human-centered system that you're going to have to interact with, you're going to need ad hoc coordination. And because humans, just by our very nature, behave in a way that is not always 100% predictable. And so you're going to need systems that are robust to the unpredictable nature of human actions.
Yeah, right on, Andy. In that one, I'll just throw in that, so we've also experimented, just like what James was talking about, establishing a trust score for machines. So machines and humans can also accumulate and earn trust in similar ways, although how it's interpreted is by human and machines are very different. So a common language of multi-machine trust is also important for even making the ad hoc coordination stuff work safely and effectively. All right, Kate's got her hand up. Kate, go ahead.
Yeah, I'm going to throw out the weather is an ad hoc player on the transportation, and I'm sure with the other folks here. And so trying to get spot weather warnings in order to reroute folks, or a wind gust that blows over an 18-wheeler that causes a crash, and you want to get the information back further so that people can divert or the system. So there are things other than just humans that don't always follow particular patterns. So that's another challenge that we're looking at.
That's right. Yeah, humans are like the weather in that regard for sure. Thank you, Kate. All right, I'm going to jump to our next toss-up question. I'm going to use this one. So many connected autonomous machines present an inviting cyber target. Compromise one machine and use that to infiltrate the entire system. So for any of you guys, as a toss-up here, what are your thoughts on making autonomous systems more cyber secure? I know Kate would like to take this one.
I'm chomping at the bit on this one. Yeah, and we have actually worked with this a lot in the connected vehicle world with the security credential management system, which isn't always considered to be a cyber solution, but it really is, because it's verifying and checking who can talk to who, and if they're actually who they say they are. We've even gone as far as doing some misbehavior detection to try and probe in to see what happens if you do crack in. So yes, it's very important. It's something we care about. I won't even get into larger traffic management systems, and as states and localities need to control their roadways, there's a whole huge other area for a cyber attack.
Awesome. Any other takers on the panel for the cyber question? All right. If not, I'm going to move on to our next one. Thank you, Kate. Our next question is, the community often talks about ensuring trustworthy autonomy, but what does that mean in a practical sense? Andy, go ahead.
Well, in aviation, our systems have to be certified before they can operate. And so there is a formalized step that the aircraft and the systems on board the aircraft have to go through to demonstrate that the system as a whole is trustworthy. And if it's an autonomous system, it's going to have to go through that same process. And the process for software relies heavily on a development assurance approach, where the process of developing the software is scrutinized. And that approach does not really embrace non-deterministic systems. And as you go to an autonomous system that has to behave in all of these complex environments and deal with ad hoc coordination, et cetera, you're often going to have non-deterministic approaches in your software. And it makes it really difficult to certify. And so one of the areas that the aviation community, including NASA, is looking at right now is how do you do what we're calling autonomy assurance, or how do you develop the assurance case associated with an autonomous system as a step toward the certification process. And so it's that certificate. We have a formalized process, but we have to come up with the techniques to be able to demonstrate that our systems meet the standard. And a lot of that has to do with the purpose of the design system. Now, I gave the example of an emergency autoland system that is autonomous. The FAA was able to certify that system because it's only used when basically the aircraft is lost anyway. And it's a pure safety net that it doesn't have to be perfect, but it has to be better than certain catastrophic event occurring. And so the FAA is taking a step by certifying this system to be used. And the thing that they focused on is that it won't accidentally behave when everything is fine. That was the main thing, was that it didn't kick off when it wasn't needed. And as long as it behaves itself when everything is going well, it is considered good enough, and it uses AI and machine learning techniques, for example, to select an appropriate airport. No one knows ahead of time what airport it's going to select as its emergency landing point. It's going to pick the best available based on a set of criteria, and circumstances would determine it. So anyway, that's the one approach that the aviation community is pursuing.
Great. Thank you. Greg's got his hand up. Greg, take it away.
Yeah, I just want to echo what Andy was saying. I mean, in the Department of Defense, it's the same way. I mean, it ends up being a risk proposition discussion. So if the benefit outweighs the consequences, you know, in that scenario like you just gave, that's exactly, in a way, that's sort of a crawl, walk, runway approach, because you assume that the more we get comfortable with that, the more we're going to sort of stretch that risk a little bit. And then, you know, even in like the experiments we're doing now, you know, we're probably doing things that we'll never do, at least for years, but it allows the ability to develop that trust and, you know, with the operator and with the machines themselves. Over.
Great. Thanks, Greg. All right, so I'm going to jump to one last toss-up question before we go into our lightning round. That the panels know what that means, where we do just a quick question where each panelist gives a short answer to it. But this one's the last of our toss-up, and it's the one that I get the most frequently, honestly, from people who've just watched the movie Terminator. So how do you see keeping humans, quote, in control of these systems at the most extreme level? How can we keep from building Skynet? So that's definitely a Terminator reference. Or more practically, how can we avoid negative unintended outcomes? So any takers out there for the Terminator fans?
I think I can say a few things in what we do.
Sure.
When we, for example, design algorithms for autonomous driving, we put some constraints. So things that they can do, they cannot do. So we constrain the solution space so that the control algorithm doesn't go berserk and then doesn't start doing unsafe things. So it kind of, so basically we call it making it robust to things that are going on. Obviously, that reduces efficiency, but that's kind of a trade-off between safety and efficiency. And then we try to design algorithms to do that. Is it 100% bulletproof? It's not, but it really reduces unsafe behavior at the design level. Then obviously you have to go and test it in the real world and how it works. Maybe add some other heuristics like Asimov's iRobot, like thou shalt not hurt a human being, or thou shalt not kill a human being, something like that. You can put some heuristics, but also at the design level, you can build algorithms that are relatively safe in terms of operations.
Great. Thank you, Khan. All right, so with that, I'm going to move on to our toss-up section. As I explained just a little bit before, this is just a quick response from each of the panelists. I don't know exactly what the right amount of time is, but in some cases we'll just ask you for an integer score. That's the last one. But one actually is one that Andy suggested. I'm gonna throw it out as our first one, which is, what is one myth about autonomous systems that you wish could be refuted? So I don't know if there's a quick answer to that one, but if you have a short answer, or you I'll make that the last toss-up. If you want to raise your hand, that's fine. About the myth. I think we talked a little bit before about the folks with the cars that think they can drive themselves. Go ahead, Andy.
One myth is that autonomous systems don't involve humans. Humans are always involved,
Sure.
and their role may change. They may move from a direct control role to a management role or an oversight role, but humans are involved, and humans are still accountable for the behavior of the systems that they've authorized to do something. And so, you can delegate the responsibility for the action to the software and the automation. but the accountability of what happens when you turned it on still rests with you when you turn it on. And so that's a myth in my mind.
I think one myth that very quickly, they will happen next year. I've been working with autonomous vehicles since 1994 on a US DOT project, actually, when I was a PhD student, and they were saying the same thing. In 2 years, we'll have like a completely automated vehicle system. It's not going to happen next year. I think that's the biggest myth, probably.
I'm going to take a twist on Khan's myth, which is they're here now. There are versions of automated autonomous vehicles, but they are not here for you to buy. So kind of my mantra. I mean, we hope we're getting there, but yeah, that car that you bought that the dealer claimed was an automated vehicle is not.
All right, Greg, you got a myth for us?
Yeah, I think internally our culture is that we're going to sort of buy it off the shelf and it's going to work, right? And I think in reality we realize that we sort of have to sort of raise it and grow it because it's got to get used to our environment in order to actually be, smart and productive. So it's almost an opposite of the way we currently acquire technology and solutions. So that's something we have to overcome.
Right on. Yep. Real world is messy. Requires a lot of adaptation. All right. So for we will do the lightning round here now with the quick one on the scale of 1 to 5. 1 being almost no progress, and 5 is nearly all progress has already been made. Where are we in your domain in realizing autonomous systems and the potential benefits? So we'll go in reverse order. Greg, you gave us the last myth. So on a scale of 1 to 5, in your domain, 1 being no progress, 5 being all progress already made, where do you see autonomy and being the potential benefits being realized?
I would like to say just a 2, and that's obviously just my opinion. I think we have a ton of opportunity to go, but I think right now we're sort of we're sort of crawling right now.
Right. Yeah. So pretty low score. How about you, Kate? 1 to 5. Where do you feel like the connected automated vehicle world is in terms of its top end benefits?
I'm known as a tough grader, and I'm 1.5.
Okay. Yeah.
It's not progress, but we got a long way to go.
Explained about the number of significant digits allowed in the response. Well, 1.5 is totally appropriate. That's great. Thank you, Kate. Khan, how about you? In terms of the world that you look out the window and see, where are we in terms of autonomous systems?
I think we are 2.5 or 3, but that 2, that remaining 2 is bigger than that 3. So it's like I want to be an optimist, but I think that it's a nonlinear function. Going 0 to 3 is not maybe that difficult, but 3 to 4 will take longer time. So I'm looking at it as a nonlinear system.
Awesome, great, thank you. And Andy, where do we fall on your scale?
Now you asked for an integer answer, and we had 2 non-integer answers. We don't have rule followers here, but I noticed that we're all what might be interpreted as pessimistic. I'm kind of falling in the 1.5 camp. By the way, it may sound like we're pessimistic, but I think just the opposite. I think we're optimistic. I think we see, while we've come very far, I think we all see a great potential ahead of us in terms of what we still could do with this technology and the capabilities that we can still unleash. Now, how fast are we going to get there? I'm not sure, but I'm optimistic that there's much more to be done and much more benefit to be realized.
Right on.
I mean,
yeah,
Carl,
I think
if you allow me, I want to say something because I give this example. I mean, I don't know. We are all we will remember. The younger students will not. There was something called Apple Newton. It was like an iPad. And I bought that. I could never use it. And then my wife gave me a very hard time for spending all that money and not being able. It didn't work. And then now, so there's a right time for certain technology to work. Maybe one thing, maybe wireless. I mean, I'm not an expert in iPad, but then iPad works for everybody. Everybody has iPad, but Apple Newton, although it's very similar, never worked. So I think the right time, right technology mix, and right population, whatever, I mean, makes that work. So I think it's not that straightforward, just having the best car and then it will work all of a sudden overnight. So I think that's kind of the example I give to my students, so.
Awesome. Thanks, guys. Well, I think we're getting close to wrap up here. I do want to reward Chuck Bristow, who's been putting some comments in the chat here. I would like to maybe throw one last toss-up question at our panel before we call it a day here from the Noblis Autonomous Systems Lab. So I'll read his question. I think the first one may be the most salient for this group. Chuck asks about the safe and effective operation when the autonomous machine is less than 100% capable. So that is a car with a loose wheel or a UAV with a faulty GPS. I mean, machines deployed in the world are not going to be perfect, just like people, right? Andy said people are unpredictable, but machines can also be unpredictable. So I just know if anybody would like to raise your hand if you'd like to take a question on managing machines that may not be acting like they ought to be or may be damaged. Go ahead, Andy.
From an aviation standpoint, that is the hard part. Making the aircraft fly when everything's going fine is not as complex as being able to deal with all of the potential off-nominal, even minor off-nominal situations that may occur, whether it be degradation in the GPS signal or whether it be a faulty rotor. Whatever it may be, you always have to be able to deal with the off-nominal situation. And so it's just like programming, data analysis. It's dealing with the exceptions is the large part of what the programming is involved with. Well, dealing with autonomy, it's dealing with the exceptions in the environment and in the circumstances that requires the most work, and being able to demonstrate that you can respond appropriately in all of these situations is the key.
Awesome. Thank you, Andy. Well, I see we're at 4:25. I did want to make a moment to see if Chris has any thoughts in terms of a wrap up before we thank our panelists and let them get back to solving all these problems. I will say though, real quick, is that my hypothesis going in was that you guys would have something to talk about with each other. So I feel like as an experimentalist, the hypothesis I was supported. I'll do the statistical analysis afterwards and report the significance. But that's my observation for today.
Yeah, I think your assessment there and your hypothesis vindicated, Carl, in terms of getting the group together to talk about some very interesting trends and issues in the space. I mean, I think fairly blunt, feedback in terms of kind of where we are and where we need to go. So I think just wanted to say thank you to our panel. Really appreciate your thoughts and insights and sharing those with us today. So.
Right on. And to close out here, I'd just also like to add my thanks to Chris's. I really appreciate our panelists, also the participants who've been joining us remotely and asking questions. Thank you for your active participation. And as a closing just remark, if you're interested in some of the stuff we've been doing here at Noblis, please visit our Noblis Autonomy website. You can just search for Noblis and Autonomy. You will find it. Some of the videos that we showed today and others are there. There's more information on, again, our worldview and why we think it's important. Again, a key thing that I think folks have said is in some ways it's not the technology. It's setting up the rule sets for these machines and humans to work together more effectively. And I think that's going to take everybody, not just the folks in our lab, but across all these domains to make it happen if we're going to realize the tremendous benefits that I think we're going to get from operational deployment of a large-scale, resilient, self-organizing, reconfigurable autonomous systems. And with that, I'm going to stop my monologue. Thank you, Chris. Thank everybody in the room here for making this happy. Thank our panelists, and thanks our participants. So have a great day. We look forward to getting together with you virtually, otherwise, in the future. Have a great day.